Hello mathematicians. Thanks for joining us for another one of our demonstration videos of Classpad.net. In this particular video we'll be focusing in on the Calculate Sticky and some of the features you can access there. In order to do so, rather than create some random problem I'm going to make up, I thought we would use a problem generated for us by our friends over at TheMathContest.com. That's a math competition put on by the University of Mississippi, also known as Ole Miss. So as you see, this was the problem for the week of April the 30th. And in this problem we're asked to find the sum of the following expression: 376 squared minus 375 squared plus 374 squared, and on back and forth all the way down to 2 squared and then minus 1 squared. Anytime I see a problem like this, there's a pattern here, but I can see that alternating positive, negative is going to create some headaches for us. We want to somehow get that alternation out of there. Now, one way you could do it is maybe to split all the positive terms and all the negative terms. That might work. But the thought I had was to just take a quick look here and see if maybe there's a pattern if I group them in clumps of positive and negative terms. So if we take a look at 376 squared minus 375 squared, let's see what we get. Alright, now let's try 374 squared minus 373 squared. Oops, it would help if I put in an exponent. Now let's try 372 squared minus 371 squared. Okay, I'm seeing a pattern. Are you seeing a pattern? It looks like we're dropping by 4, we're dropping by 4. I anticipate this is going to continue all the way down to 4 minus 1, which will give me a 3. So using another little sticky note here, I'm going to put a little note to myself. We're really looking at a pattern of the form 751 plus 747 plus, let's see, 4 less, 743 plus ... all the way down to, let's see, we end at 4 minus 1, which is 3. So something like this. Hopefully that makes sense to you. Now, this is interesting. It's simplifying our life a little, but it's not exactly going to give us an obvious solution. Some of you may be getting excited because some of you may know how to solve this sort of thing. If you've not seen this, one nice handy way to solve a repeating sequence of numbers is to use a technique very similar to one attributed to Gauss. There's a great little story about as a child how he quickly added all the digits from 1 to 100 by using a technique very similar to what we're going to show you here. If you've not seen that, I advise you to look it up. It's a great story. So the trick for this kind of a sequence is to pair up the numbers, the highest number with the lowest number, and then the next highest number with the next lowest number, just to maybe make it a little more symmetric. Let's do that. So I'm going to, underneath this, pair up these numbers in reverse. So 3 plus 7 plus 11 plus etc. Just for you to get a visual idea of what this looks like. So notice now, if I create a little computation space, that if I take 751 plus 3, this first pair of numbers, I get 754. If I take 747 plus 7, the next pair of numbers, I get 754. And so on, all the way down the line. So each one of these pairs vertically, I didn't line them up very well, but each one of these pairs adds to 754. So, in order to quickly sum all of the numbers I have placed here, all we need to do is figure out how many pairs adding to 754 there are. And we've turned this into a multiplication problem. Now, you may recall that up here we have originally how many numbers? 1, 2, 3, all the way up to 376. We have 376 values here. But when I treated them like this, I grouped them into clumps of 2. So actually, instead of 376, I cut each group in half. So instead of 376 values, we have half of 376. Some of you might want to do that in your head, but we have a calculator here. We have 188 of these pairs. So if I take 188 of these times 754, I get the complete total. And there's just one catch. I have these numbers listed twice, right? So to fix that, after we get the complete total, we're going to cut it back in half. Again, the trick here is you double it up to make the counting easy, and then afterwards you cut it in half again to remove the extraneous numbers. So let's do that. Create a fraction. We have 188 times 754, and again we're going to divide that by 2. So we expect that the sum of this is going to be 70,876. Now, it'd be nice to verify this independently in a different approach, and some of you might like to see some of the more powerful features of Calculate, so we're going to do that over here by showing off the ability under the Math tab, tab number 2 here, to use summation. And what summation is, if you've never seen it before, is a quick way to add up a sequence of numbers that follow a pattern. And the only real trick here now, this is going to do all the heavy lifting and all the hard work, we just have to tell it the right kind of pattern. And that's where the challenging part comes in. So first of all, we need to tell it how many numbers. Where do we start and where do we end? So 1, 2, 3, all the way to 376. So I'm going to say let some variable, we'll call it n, let it start at 1 and run to 376. And now, using those numbers from 1 to 376, I need to create a pattern that will generate minus 1 squared plus 2 squared, etc. Well, the 1 squared, 2 squared, 3 squared is easy, right? We're just squaring every number, 1 squared, 2 squared, all the way up to 376. So that part's easy. The trick that we need to do is figure out how to make this alternate from negative to positive to negative to positive. And rather than go into a whole long explanation, I'm going to sort of shortcut that here because that's getting a little harder to explain in the time we have. But just look at this handy little trick involving negative 1 to the nth power. Think what happens if you have negative 1 and n is 1. I just have one negative 1. That makes it negative. If I have two negative 1s, negative 1 squared, they multiply and become positive 1. If I have 3, they become negative. 4, they become positive. And back and forth all the way for the duration. So alternating negatives and positives, every other term is n squared. We add them all up, and it's 70,876 as we expected. So there's a lot more features involved in Calculate. We just wanted to show off a brief glimpse and hopefully do a problem that you would have some fun solving with us. So thanks for your time. Keep an eye out for Classpad.net and keep an eye out for us on YouTube. And if you like us on social media. Thanks.